Okay, guys, it is Wednesday, April 1st, 2020, our third day of our new 9 weeks. Advanced Math Honors classes, Mods 2, 3, and 4. Get a sheet of paper out, ready to roll with what will be our note-taking experience for today. Top left corner, today's date is 4/1/20, April 1st. Word problems is the name of the topic, and in parentheses put law of sines and cosines. Obviously, the last 2 days, Monday we worked on law of sines, Tuesday we worked on the law of cosines. Now we're going to kind of put those all together and show how they can be used to solve application type word problems, just like we did after we learned SOHCAHTOA, with angles of elevation, angles of depression, height of buildings, things like that. Now to do this today, first of all, good news, there's no homework tonight. All you've got to do today is take notes right along with me, draw the pictures, set up the problems right, and take a good set of notes as if you were sitting in class. When you're done with these 4 problems, and we're done doing these together, all you got to do is take a picture of it, email it to me, and you get a 4-point homework assignment or daily grade for this assignment, and it's just purely on effort and completion. If you can get all 4 of these done and completed along with me today as we talk our way through them, send me a picture of your notes, then everybody's going to get 4 out of 4 for a completion grade just for completing their notes. This is really just kind of a wrap up and a tie together for what we've learned the last 2 days. And if you just show me that you've paid attention, followed along, and wrote down the steps to these problems, you'll just have a 4-point grade for today's topic, okay? All right, here we go. First of all, if you do get on Schoology, you can click on and take a look at the 4 word problems we're about to do. You can actually, I would think, have some ability to take a picture of them or print them out and have them in front of you if you so choose. However, I've got a picture of our 4 problems right here. Here they are. We're going to try these 4 together. So let's attack these, starting with number 1. Looks familiar to a question we've done in the past. It says, from a certain distance, the angle of elevation to the top of a building is 17 degrees. Okay, let's freeze right there. From a certain distance, so that distance is irrelevant, I'm looking at a building, I look up at the top, and the angle of elevation is 17 degrees. So, on our paper, on our notes, we're going to pick a starting spot, and that's where we're standing right there. From a certain distance, I'm looking at the top of a building, and as I look to the top of the building, my angle of elevation is 17 degrees. So far so good. We've seen that before. All right, let's go back to the word problem. It says, at a point 50 feet closer to the building, the angle of elevation is 31 degrees. And I'm supposed to determine the height of the building. So all I've done in this problem is I've walked closer to the building, let's say right here, and I walked 50 feet closer to the building. So that's a value, of course, of 50. And now as I look up to the top of the building, my neck would be, oh my goodness, pointing backwards a little steeper here. The angle of elevation to the top of the building is now 31 degrees. Okay? All they want to know is, based on this information, determine the height of the building. How tall is that building? So I'll put a big old H for the height, and that's what we're trying to figure out on this problem. Of course, where the building meets the ground is our right angle. This should look very similar. We did a problem just like this when we did SOHCAHTOA. If you remember, we called the bottom side of this little triangle Y. We did the sine of 31, the tan of 31 equaled H over Y. Then we did this tan of 17 equaled H over 50 plus Y. We had to set those and we did lots and lots of work to finally eventually figure out a way to calculate the height of that building. Well, think about this. If I look at this picture, does everybody agree that if I was trying to find the height of this building, it'd be great if I could figure out how big the hypotenuse of this little right triangle would be? So that hypotenuse, I'm going to call X for right now, because think about it. If this is a straight line right here, and this is a 31-degree angle, isn't the angle right beside that, since they are a linear pair, going to be what, 149 degrees? Because 149 plus 31 adds up to 180. And now in this other triangle that we've got here, if that's 149 and that's 17, that adds up to what, 166? That means this corner is 14 degrees. So if you now look at that picture of that triangle on the left, can I use the law of sines to figure out side X real quickly here? Think about it. Obviously, this side X that I'm seeking is across from that 17-degree angle. So I can say X over the sine of 17 equals, and then we already knew this side was 50, over top of what angle is across from him? The sine of 14 degrees. So using the law of sines, I was able to set up a proportion, and now I can solve for the missing side X. So cross multiplying, I would have X sine 14 equals, cross multiply this way, I'd have 50 sine 17. Of course, to get X by itself, I divide by the sine of 14. And basically, when those cancel out, side X, that missing side I was looking at, I've got my calculator right here. I'm going to push 50 sine 17, hit enter. Divide that by the sine of 14, hit enter. And it looks like the missing side is 60.4. Again, we'll go to the nearest tenth. So does everybody agree if that missing side is now determined to be 60.4, and that's the hypotenuse of my right triangle, I can now find the height of the building, which was my goal all along, by doing what? Opposite over hypotenuse. So wouldn't that be what? Sine, the sine of 31 equals opposite, which is h, over the hypotenuse, which is 60.4. Since he's understood to be over 1, I'd cross multiply and end up getting h equals, of course, all we're doing on our calculator is pushing 60.4 times the sine of 31. Go ahead and do that on your graphing calculator. And I'm getting a height of 31.1 to the nearest tenth. So we were able to solve that same problem that we had earlier this year, now by using the law of sines in conjunction with SOHCAHTOA to find the height of that building that we were seeking. Okay? Hope that makes sense. Problem 2, if we take a look at it, says the following. It says, find the height of a tree that stands on a hillside of slope 28 degrees. If from a point 75 feet down the hill, the angle of elevation to the top of the tree is 45 degrees. All right, let's slow the game down here and draw that picture one thought at a time. It says, find the height of a tree that's standing on a hillside of slope 28 degrees from the horizontal. All that means is, here we are at ground level. There's the horizontal value they talked about, the ground. This is a hill, a hill, a hill, a hill. And at some point on that hill, we've got a tree. And we want to know how tall is that tree. So that height of that tree is what we're looking for. And remember, the slope was 28 degrees right there. So far, so good. Obviously, I could extend this side down and make a right triangle here if need be, because that's probably going to be important. Now, reading the next part of the question, it says, if from a point 75 feet down the hill, the angle of elevation to the top of the tree is 45 degrees. Oh, so now 75 feet down the hill, so that distance is 75. I look to the top of the tree, and the angle of elevation is 45 degrees. Now think about it. That would be this entire angle right here, wouldn't it? That whole angle of elevation to the top of the tree is 45 degrees, which should make this little angle 17, right? Because 28 and 17 adds up to the 45-degree angle of elevation that they just mentioned. And they want me to figure out the height of that tree. Well, let's see what we've got here. That's my H, isn't it? Oh, I got an idea. This corner is 28 degrees. This is obviously 90 degrees. So in that right triangle, if I add 90 plus 28, that's what, 118. So my missing angle, 180 minus 118, would be 62. Again, we notice a straight line right here, so that's called a linear pair. If that's 62, the angle right beside it is 118. Oh, and if that's 118, and this angle is 17, that adds up to what, 135? So the angle at the top of this triangle would be 45 degrees. All right? So why is that important to note? Well, if we know that this side of our triangle, remember, was 75 feet, and that's across from this angle, which is 45 degrees, oh, can't we say 75 over the sine of 45 equals, now remember we were seeking the height of the tree? We could do H over, and then how big is the angle across from him? 17. So write the sine of 17. So cross multiplying, we've got H sine 45 equals, cross multiply there, we've got 75 sine 17, divide by the sine of 45, and we should figure out the height of the tree. So once again, law of sines became useful to figure out the height of the tree on that picture. So I'm typing 75 sine 17, enter, divided by the sine of 45. If you do the same thing on your calculator, we should get, I'm getting 31.01, so about 31 for the height of that tree. Okay? So two problems where we ended up using the law of sines to solve that little application situation. Okay? Problem 3. If we look at it right here, it says to approximate the length of a marsh, a surveyor walks 425 feet from point A to point B. Okay, let's do that right now. We're in block number 3 on your homework. We've got a surveyor. Here's point A. He walks 425 feet to point B. So I will put 420. That was simple, right? Again, the surveyor walks 425 feet from point A to point B. Okay, the question now says, then the surveyor turns 65 degrees and walks 300 feet to point C. Now remember, the surveyor was walking, got to point B. He then turned 65 degrees. So he turned 65 degrees. So we'll do this and walk 300 more feet to point C. So I'll put 300 right here on that side. All they want to know, again, read the rest of the question, determine the length AC of the marsh. Oh, so they want me to simply find how the length of the marsh from A all the way to C. So that length from A to C, I'll call that L, is what we're looking for. Okay, what the heck would we do here? Certainly don't you dare say A squared plus B squared equals C squared and try Pythagorean theorem. It's not a right triangle. So Pythagorean theorem is not an option. SOHCAHTOA is not an option, at least not at this point. The thing I'm thinking, once again, here's a straight line. Everybody agree? And this was 65 degrees. So if I said, how big is this obtuse angle right here? We would take 180 minus 65, get 115. Now that should look awful familiar from something we did yesterday. Remember that thing called the law of cosines? When I'm looking for this case side L, and I've got the angle that's across from him and the two sides coming together to create that angle? That looks to me like a straightforward law of cosines question from that point right there. Couldn't I just do L squared equals, and then what? 425 squared plus 300 squared minus 2 times 425 times 300 times the cosine of 115, because we're taking the angle that's across from that missing side. So bottom line is, to make a long story short, you could now then square 425 and square 300 minus 2 times that big number times that big number times that guy there. You can literally type all that into your calculator and seek an answer for this problem at that point. So I'm going to do all that on my calculator at one time. You should be able to type all that in there. So here I go, 425 squared plus 300 squared minus 2 parentheses 425 parentheses 300 times cosine of 115. I'm getting a really large number on the screen. It's like 378,392 point blah, blah, blah. Everybody agree? And then, of course, I square root both sides. So square rooting the number that's on my screen, it looks to me like I'm getting 615.1 feet. Wow, is how long that marsh is from point A to point C. And finally, our last problem of the day, and you're done. All you're going to have to do is take a picture of this and send it to me to prove that you took the notes like I asked. We're kind of wrapping up law of sines and cosines and showing that they can be used in real life situations here. Problem number 4. See if this looks familiar. 2 planes leave an airport at approximately the same time. One is flying 425 miles per hour. Remember, that's just telling us how fast he's going. At a bearing of north 5 degrees west. Okay, let's pause and think about what that looks like right now. Here I am. Here's the airport. I've got a plane that's going to fly at a 5-degree northwest bearing. So if you draw your vertical axis and your horizontal axis, if that plane is driving or flying at a northwest 5 degrees, that's north and that's west. So a northwest bearing, he's heading in the northwesterly direction of 5 degrees. Remember, the bearing always touches the vertical axis. Well, if we go back to that problem, another plane is flying 530 miles per hour. His bearing is north 67 degrees east. Oh, so that same airport, I have a different plane. Instead of going northeasterly, excuse me, instead of northwesterly, he is traveling at a northeasterly direction. So he's going this way, this way, this way, and flying at a northeasterly bearing of 67 degrees. Once again, that bearing is touching the vertical axis. And they want you to determine the distance between the planes. So how far is it from that plane to that plane? That's the distance we're seeking after 2 hours. Oh, determine the distance between the planes after they have flown for 2 hours. So if the first plane was flying 425 miles an hour for 2 hours, that'd be what, 850? The other guy was going 530 miles an hour for 2 hours. That'd be what, 1,060. So we will label the first plane's distance traveled as 850, and we will label the other plane's distance traveled as 1,060. And the second you look at that, can't you set that up and solve it the same way we did this one over here? Wow, it makes things a lot easier, correct? So if I look at that picture, wouldn't your setup simply be d squared equals, and then we would take what? 850 squared plus 1,060 squared minus 2 times 850 times 1,060 times the cosine. Now careful, that entire angle would be what? 72 degrees. Agreed? So go ahead and finish that. Use your calculator. Literally type 850 squared plus 1,060 squared minus 2 times 850 times 1,060 times the cosine of 72 times all that on your calculator. Of course, since it's d squared equals that big number, you would square root both sides and see if you can tell me the total distance between the airplanes when they're done flying after 2 hours. Okay, guys? So for 3 days, we worked on law of sines, law of cosines, kind of put those formulas together in some application word problems today. We're all set on that topic. That kind of finished our trigonometric right triangle work that Mr. DeMarco wanted you to do. We're done for the day. You simply take a picture of your notes that are completed and finished. Send a picture to me. You'll get 4 out of 4 for getting credit for just attempting and following along and doing the work. And we'll start a brand new chapter called conic sections tomorrow on Thursday, April 2nd. Okay? Thanks. See ya.